Welcome! NOAA has just released its climate review for 2023. You have no doubt heard that 2023 was the hottest year on record. Let's see how that came about and what it means for 2024. A quick summary of what we're going to cover today. As I said, 2023 was the hottest year since modern records started. That's in 173 years. It's likely worse than that. 1850 marked the end of the Little Ice Age, when global temperatures returned to something like normal. The Little Ice Age started in the 1350s, so that's something like 700 years ago. The data indicates that our current temperatures are the warmest since the Holocene maximum of over 7,000 years ago. If we pass that mark, which seems likely soon, if we've not done so already, we would have to go back over 130,000 years to find equivalently warm periods. It's not just the surface, but the higher altitudes of the atmosphere are warming too. The whole atmosphere is warming. Global sea ice is shrinking as the seas warm. Adding to current temperatures is the effect of El Niño, which is likely to remain with us at least until the spring. Atmospheric CO2 reached its highest level in over 3 million years. Let's see how various parts of the world fared in setting this new high temperature record. North and South America and Africa had their hottest year on record. Europe and Asia had their second hottest. Meanwhile, the South Pacific was at its 10th warmest. The northern and southern oceans also posted record high temperatures. As a result, the Arctic had its third smallest winter maximum sea ice cover and sixth smallest summer extent. Even more extreme situation was in Antarctica, where both the summer and winter ice coverage was set new record lows. Here we have the annual global temperatures since 1850. The baseline level for this is the 20th century average, which, as you can see, contains a significant amount of warming already, starting in about 1910. 2023 did not edge out 2016 as the hottest year. It smashed it by nearly 0.2 degrees centigrade. That's a huge change in global climate terms, and may mean the rate of global warming is accelerating. Let's see how the heating was distributed around the globe. Dark blue here indicates record cold temperatures. Note there are none. Dark red indicates record high temperatures, and there are a lot of those. In fact, much of the globe is either at record high or much hotter than average. There is actually almost no blue on the map, so very little of the planet was below average. Note the swathe of warm oceans off the west coast of South America. That's El Niño, and is still looking quite healthy. We can look at this another way by comparing the numbers of record high temperatures logged compared with the number of record lows. If the two are a statistical dead heat, forgive the pun, then the Earth's climate is approximately balanced. If record highs are significantly greater than record lows, the Earth is warming. Of course, if the reverse is true, then the Earth is cooling. So let's see which is the case at the moment. Comparing the daily records, that's top left, we find that new record highs outpace new record lows by a margin of 3-1. Monthly records, bottom left, are much more difficult to set, but even so, the new highs are greater than the lows by a margin of 4-1. Setting all-time highs, right, is hard. The data show that new highs are significantly more than lows by a margin of nearly 5-1. The only viable conclusion here is that the Earth is warming rapidly. We're used to discussing the temperature at the surface of the Earth, i.e. where we live. However, heating is occurring at higher altitudes as well. The satellite data, which measures these temperatures at high altitudes, falsely claimed by some to show no warming, has a significant upward trends of about 0.13 degrees centigrade per decade. However, look at the last few points on the right of the plot. That's 2023. Note how, like the surface temperature, it eclipses the previous highs. One level of the atmosphere is actually cooling. That's the stratosphere, not shown here. This actually establishes the source of the warming. That layer is heated partly by the sun and partly by outflowing IR radiation from the Earth. The sun has not changed, so the only explanation that this region is cooling is that there's less IR coming up from the Earth. That is uniquely explained by the scattering of outgoing IR by increasing amounts of greenhouse gases in the atmosphere. It confirms that carbon dioxide and methane are primary reasons for global warming. Sea ice seems to occupy a lot of some people's attention, even though it does not affect global sea level. However, it does affect the energy balance of the Earth, as ice reflects away a great deal more sunlight than open oceans. First, let's take a look at the Arctic. Sea ice there has shown a steady decay in area of about 3% per decade since 1980. At the beginning of January, sea ice was at its third lowest extent on record, over 420,000 square kilometers below the 30-year average. Until recently, the Arctic was showing a different trend, with little or no change of sea ice area. However, in the last few years, it has shown a rapid decay, and the long-term trend has turned negative for the first time. January of 2023 was the lowest sea ice extent on record for the Antarctic. Overall, global sea ice picture is not looking good. For January of 2023, it was at its lowest extent, nearly 500,000 square kilometers below the 30-year average. The Earth is losing sea ice at a rate of about 2.5% per decade. El Niño has a major effect on global weather. At the moment, we are in a moderate El Niño, shown here by the tongue of warm water off the South American coast, stretching almost to Australia. This raises average ocean temperatures and provides more heat to the planet. The question is, how long will it last and how strong will it get? Here is the plot of probability of El Niño conditions lasting into 2024. El Niño is indicated by red bars, ENSO neutral conditions by grey, and La Niña conditions by blue. It seems we will have El Niño conditions through the Northern Hemisphere spring. As it decays, we'll be in for a period of ENSO neutral conditions, followed by a likelihood of a La Niña later in 2023. It should be noted that historically the Earth continues to warm for several months after an El Niño has decayed away. That is why many experts believe that 2024 will be at least as hot, if not hotter, than 2023. We continue to make conditions worse as our industrial emissions continue to add to more greenhouse gases in the atmosphere. In December, the carbon dioxide concentration in the atmosphere reached 421.86 parts per million, naturally a new record for that month. However, there is a bright side in that increase represented only 1.87 parts per million, which is lower than we have had for a very long time. Could some of our measures to limit greenhouse gas emissions be working? The Sun is approaching solar maximum when the Earth receives most energy from our local star. Solar cycle 24 is in the middle of this plot of total solar radiance, that's the energy coming from the Sun, and is marked in orange. Solar cycle 25, the current cycle, is in red on the right. Note the peak level of solar cycle 25 is already greater than the peak of solar cycle 24. Note the dashed line. That means that there will be no grand solar minimum this time around, and it will likely not come for any time soon, i.e. many decades. What conclusions can we draw from all of this? El Niño will stretch into 2024, and global temperatures will continue to rise. This makes it possible, perhaps even likely, that 2024 will outpace 2023 in terms of temperature records. It will not be helped by the Sun approaching solar maximum. That's it for today. Thank you for watching. So until next time, stay safe and goodbye.